I'd now like to introduce Mike Hodgkinson to speak to you about Capricorn. Mike has been working in clean tech for over a decade, focusing on innovations that can solve our climate crisis and reduce skyrocketing energy prices. Prior to joining Capricorn in 2017, Mike successfully launched a financial startup in London, and he led solar systems before becoming a successful commercial clean tech consultant. Mike has a knack for accelerating the growth of forward-thinking startups through solid financial management, through considered commercialisation and relationship building. Mike's excited by Dr. Martin's brilliant technology, and Mike is driven to create a greener world for our future generations. Welcome, Mike.
Many brilliant technologies have been developed over the years to help combat our growing climate crisis. Wind power, of course, has many fans, and we need to invest more in solar PV now because it won't happen overnight. I've got more of them later. But we can't sit back and rely just on solar and wind. A massive 72% of the world's energy is wasted, leaving a multi-billion-dollar waste heat opportunity virtually untouched. We launched Capricorn Power in 2016 after recognising that there was this huge business and environmental opportunity in waste heat. Together, we've developed a unique technology that turns waste heat, which is free energy, into electricity at an efficiency that's a quantum leap above others in containerised scale. The central challenge of our age is developing ongoing human progress whilst using less resources and avoiding environmental decline. Innovative new low-carbon technologies are essential to reducing energy costs for hard-won consumers and businesses and for the environment. Innovation will also play a crucial role in the long-term future of the Australian economy, creating new technologies, jobs and opportunities. Our innovation is good business, and together we can create a better world for future generations by creating a truly sustainable and inclusive economic growth. There's plenty of growth in energy demand ahead. The world's population is forecast to reach 9 billion by 2040, and this plus growth in incomes is driving demand for alternative, clean and water-free technologies to keep societies running sustainably. Globally, investment in clean tech was over US $330 billion in 2018, an incredible 62% increase from 2008. Over the next 20 years, there will be a profound shift from highly centralised fossil fuel burning clean technologies to clean technologies, zero emissions, distributed energy, interconnected and smart energy markets. We're standing on the cusp of a renewable energy revolution and one of the biggest business opportunities in history. But it's not all good news. We're suffering a global climate crisis. From hurricanes and floods to bushfires, climate change is now, and it's getting worse. We need to transition from global growth, where people are thinking that all types of growth are viewed as good, epitomised by Gordon Gekko's Wall Street quote, speech, greed is good, to one where we recognise that some types of growth isn't good, and unfortunately we aren't on track for this. Things will get worse before they get better. But of course, this just reinforces the importance of investing in innovation now. In Australia, we've had a lost decade of low innovation and investment. The result is high energy costs, high emissions, a higher than average OECD unemployment rate, and a clear impact on living standards. When the other day I opened my water and electricity bill at the same time, I was shocked. No? How is it that an energy superpower like Australia pays so much more than others? There are two reasons you should be thinking about investing in renewable energy now. The first is that a high margin, high growth opportunity is a great business opportunity. And the second is the impact of your investment on future generations. Albert Einstein said that compound interest is the most powerful force in the universe. And what he meant was that relatively small actions now, compounded over time, will have a large future impact, in this case, mitigating climate change. We all need to act now, changing what we do ourselves, changing the businesses we support, and investing in innovation. Now let's talk a little bit about the innovation journey. It takes many years to become an overnight success. This is a story about a world-leading inventor and invention, early angel support, and regional manufacturing jobs. Of course, the final chapters remain to be written. With your help, we can write these last few chapters as a super fast scale-up with a large global sustainable impact. Local investment driving lower energy costs and emissions, creating regional manufacturing jobs, and increasing living standards sustainably, followed by global expansion and similar global sustainable impact. But back to the story. It all began in 2004. Dr. Barton, our CTO and inventor, left the CSIRO after a long and successful career as a world leader in heat engines with an Order of Australia to his name and a CSIRO medal. He decided the time was right to become an entrepreneur. Think about it, 2004. And so as his first invention, he patented and built the Barton evaporation engine. A technical tour de force running off moist air. You can read about it on Wikipedia. But not the right heat engine commercially for the moment. As Rowan has mentioned, Heidi introduced Peter Young to Dr. Barton at this time, and whilst Peter and Jeff didn't see sufficient commercial potential in this invention, what Dr. Barton showed us next was extremely exciting. The efficiency of Dr. Barton's next invention was so high, it seemed almost too good to be true. Dr. Barton, recognising the serious impact of climate change very early, designed a flow sheet to accelerate the adoption of concentrating solar power because efficiency is critical to this particular technology. I first met Dr. Barton as a clean tech commercial consultant at the time, and based on this background, I was the GM at Solar Systems, so I built 3 concentrating solar power stations, a bit of a concentrating solar power station tragic. But the commercial breakthrough was when Jeff realised that this highly efficient flow sheet, the minimum viable product was the heat engine and tapping directly into waste heat. Our commercial product next year will generate up to 2 times more electricity for similar cost. It's as though we've shrunk Loy Yang power into a green container, but of course without wasting 20% of Victoria's water and without any harmful emissions. The key point of difference is that this technology is both small and efficient. In time, However, we believe it will become the most efficient, small or large. And did I mention that the Barton engine doesn't use any water? So back in 2016, Dr. Barton had proven the flow sheet mathematically, and Peter and Jeff's job was to prove that it worked as well physically as it did on paper. So the next step was engaging an engineering firm from Geelong, I won't say who at this stage, to test to see whether the theory equalled the reality. To cut a long story short, these physical tests were designed and met, and now everyone knew that we had something really special in our hand. In fact, the test went so well that the engineering company Ostenge said they'd like to become a founding investor as well. And so Ross George, an award-winning engineering fellow, is now the chief engineer. Ostenge, of course, have won many innovation awards building technology prototypes. So in addition to our headcount of 12, we have engineering support leverage from Ostenge's team. Dr. Barton independently invented this patent-pending flow sheet, but amazingly, we discovered that a similar engine had been first built back in 1829 by a giant of the 19th century, Ericsson. Ericsson was a famous naval engineer. For example, he invented turret guns, which had a major impact on the US Civil War. In an age when the caloric theory of energy prevailed, he entered the famous Rainhill trials of 1829, which were organised to choose the best engine for the railway. Unfortunately for Ericsson, the engine wasn't ready. It was a bit too early for him, and it broke down during the race. So, does anyone know who won that famous race? Just out of curiosity, shout it out if you do. Stephenson's rocket won that race, despite being not as fast and not as efficient as Ericsson engine. Ericsson did get his engine to work reliably, but missed the window, and that was the end of that for almost 200 years. Steam engines prevailed in railway. Mobility became the next big technology domain, and internal combustion engines won that, although of course we thought batteries were going to win initially, but they're making a comeback. To summarise, we've got a favourable international search report for our core patent, and 2 more patent applications are in the works. Finally, last year we built a full proof of concept and demonstrated this at a customer site. This system used pre-loved Commodore engines. We not only proved that the system worked well, but we learned a great deal about how to design the commercial engine for customers, which is what we're raising money now to do next. So I've given you the history, what is it, and how does it work. First, we take heat from any sufficiently high temperature heat source without impacting operations. You'll see that's just a pipe taking the heat out of a furnace. We then exchange this heat into our closed loop system that uses compressed air as the working gas. And then simply turn the heat energy into mechanical energy into electricity, proven by this customer pilot last year. 150 kilowatts can operate in a 20-foot container using an off-the-shelf AS4777 certified inverter plug and play. So it's just like on-site solar PV generation, except it uses a lot less space. And our solution will include a real-time smart energy platform to optimise the energy with all the usual buzzwords, digital twin, IoT, AI, analytics. Solar and wind have made great strides in providing affordable renewable energy. Capricorn Power complements these advances by tapping into waste heat, a globally abundant resource. By being small and efficient, and especially by not using any water, this is a significant product for the global energy industry. The magic is the patent-pending flow sheet invented by Dr. Barton, which is described as a closed-loop piston cylinder recuperated braking cycle, despite Ericsson being the first. For the less technical, it's a heat engine that turns heat into electricity in a really easy and efficient way. Because it's a process innovation, we use low-cost, reliable components. Our overheads are small. We're in the market selling competitively now, and we'll scale up quickly. Our 2018 highlight was winning the New Energy Award for the Australian Technologies competition, and this year Dr. Barton's paper has been accepted and he'll talk at the World Engineers Convention. Anywhere there's heat over 300 degrees Celsius, this compact system just plugs in to reduce energy cost and without harmful emissions or using any water. The customer saves money without risk or hassle. The energy efficiency applications that are our priority markets are furnace waste heat and internal combustion energy exhaust. But as I mentioned, there are renewable energy applications which include gas flares, biogas flares, and solar thermal and bioenergy power stations. The solar thermal industry hasn't quite taken off yet, but it's heating up. In our initial markets, neither organic Rankine cycle engines nor internal combustion engines are commercial. Or doesn't generate enough electricity, and biogas damages internal combustion engines, so they need expensive gas scrubbers and maintenance costs are high. So the key point is that these projects really make a difference to emissions. We have two furnace waste heat electricity sales customers. As Rowan mentioned, Furnace Engineering is the first, and we're raising the money now to build the engines for those customers. And as I've mentioned, the Australian and global markets are huge. We're 12 passionate experts from different fields with experience from most of us from global companies, and we're well equipped to bring this product to market. Our chair, Jeff Andrews, is recognised as one of Australia's leading energy efficiency experts with multiple national awards, and he sits on ARENA's advisory panel. Director Lynn, as Rowan has mentioned, is chair of the Geelong Manufacturing Council. I'm the CEO and a serial entrepreneur with success at Citigroup FinTech in London and New York, and I've led a team of over 50 building concentrating solar power stations. I've mentioned Dr. Barton and Ross George, and I'll mention our excellent MC tonight, who lectures in innovation at University of Melbourne, but also works for us and has a strong engineering and sustainability background. To date, we've raised 1.3 million, and now we're raising 600,000 to accelerate commercialisation. In particular, we're going to build our first commercial engine with these funds to generate revenue at a customer by providing most of their electricity. As well as the thousands of tonnes of emissions reduced by these projects, this investment also allows us to hire more staff and accelerate growth. So far we've got over $300,000 in expressions of interest, so we're just about halfway. There are both enormous threats and opportunities ahead for our future generations. The great thing about crowdsourced funding is the democratisation of the investment preferences. We can now put our money where our mouth is. So to paraphrase Greta Thunberg, are we ready for the question from our future generations, what did you do about climate change when there was still time? I hope you can join us in answering not only that you invested in creating a better world, but that the financial returns were also magnificent. Thank you.